Namaskar, this is the physicist, and in this video we are going to discuss how to find the median of a grouped data. Before we get into grouped data, let us just revise the concept of the median of an ungrouped data set. Now, to demonstrate that clearly, let us take an example of a teacher. Let's say that I am a teacher and I have a few students. I decided to take a test where the full mark is set at 10. So the full mark of the paper is 10. Now the students have taken the test and I have collected the result. And I see the result like this. The result comes as 2, 2, 3, 3, 4, 5, 7, 8, 9. So how many students have taken the paper? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 students who have taken the test. Okay. And this is basically the data set that I have obtained after collecting the result. So when someone asks me to find the median, or if I want to find the median, what basically am I looking for? What is a median? A median is that mark in an ordered data set which separates the bottom half of the data points from the top half of the data points. I repeat, the median is that mark of an ordered data set that separates the bottom half of the data points from the top half of the data points. So when you want to find the median of a data set, you have to first understand that you need to have the data set in an orderly fashion. Okay, so I have got this data set in an order, but what if I would have gotten this as let's say the data set would have been given to me as 9, 7, 8, 4, 5, 2, 3, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the same data set now I have got, but this one is not ordered. So I cannot find the median based on this particular arrangement. I have to order it and get the ordered data set first. Only then I will be able to start to find the median. Okay. The first step of finding the median of any data set is to check whether it is ordered. If it is ordered, then fine. If it is not ordered, then you have to convert it to an ordered data set. So let's say I have the ordered data set now. Okay. Now, by the definition, median is going to be a mark, not the mark obtained by students. It's basically a mark that I'm going to put on the data set. That is going to divide the top half of the data points from the bottom half of the data points. So let us just generalize things. Then we will apply the generalization to this particular case. Let's say I have a data set which is ordered, and somewhere there is a median, and since the median separates the bottom half from the top half, let's say the bottom half has X number of data points, then the top half would also have X number of data points. Let's say in total I have N number of observations, okay, N number of data points I have in total. Now, if the median itself is a data point in this particular data set, then the total number of data points I would have is X plus 1, because that is one of the data points. So it's going to be X plus 1, that is going to give me N. That implies 2X plus 1 is going to be N, right? As we can clearly see that 2X plus 1, no matter whatever the value of X is, going to give me an odd number. That means if this is the case, then N is going to be odd. Okay, let's say N is odd, then we'll consider what is, how do we find the median in the case where N is even. So in this case, I have to find not the value of X, I have to find the X plus 1th term, because this one is 1 data point. So you have to go from first, second, third, fourth and up to the point X, and then X plus 1. So you have to find the X plus 1th point, that is going to correspond to the median. So how do you do that? From this equation, you have to find x as n minus 1 by 2. To find the x plus 1th term, you have to add 1 to both of the sides, which is going to be n minus 1 plus 2 by 2. That gives you n plus 1 by 2 term. So this is for the odd case. Do we have an odd case here? Yes, of course. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for our case, n is 9. So what is the median mark? Where is the median mark? The median mark would be n plus 1 by 2th term, which is 9 plus 1 by 2, which is 10 by 2, which is 5th term. So counting from the left or from the right, 1, 2, 3, 4, 5. Then from the, if you count from the right, 1, 2, 3, 4, 5. So 4 definitely is the 5th term in this ordered data set. That is going to be the median. Now you can see, if you put a mark here, number of observations below it are 2, 2, 3, 3. So basically 4. And here also 5, 7, 8, 9, 4. So there are 4 data points below it and 4 data points above it. So that's the case for the odd number of points. What if the total number of data points is even? In that case, or let us just simplify or modify the example that we have by adding, let's say there is a student who's got just 1 out of 10. Okay. In this case, n becomes 10. Now, if we apply the same logic that in this data set, arranged or ordered data set, this is the median mark and bottom half will have x points and top half will have x points. Total number of points, n is going to be 2x. If this point comes as one of the data points, then 2x plus 1. So this is even, but this is certainly odd. So this equation is not valid anymore. So we have to, what we have to do is to understand that there would be 2 points, the xth point, which is the topmost of the bottom half, and the x plus 1th point, which is the bottommost of the top half. This is the bottom half, this is the top half. This xth point, which is the xth point, which is the topmost of the bottom half, and this point, which is the x plus 1th point, which is the bottommost of the top half. So you have to average them out. That is actually very easy. How? Because we know that there are total number of points as n, which is basically x plus x. So 2x is n. So we know x is n by 2. So that gives you the topmost point of the bottom half. Then for the x plus 1, you have 2n by 2 plus 1 point. That gives you the bottommost of the top half. So you have to average them out. So if you want to simplify this case, I mean apply what we have just obtained. Like if n is 10, then n half, the n by 2 point is the 5th point, and n by 2 plus 1 point is the 6th point. So you have to find these 2 points and then average them out. So you have to find the average of these 2 points. So what are those? What are those points? 1, 2, 3, 4, 5. This is the point, 5th point, and then the 6th point is this. And then you have to average them out. So the average point, the median will not lie here. The median will lie here. It will have the value 3.5. Okay. The median mark is set at 3.5, and this is not one of the data points in the data set. But there would be how many points? 1, 2, 3, 4, 5, 6 are below 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So 5 will be below that mark and 5 will be above that mark. Now, what if instead of this 4, we had 3? What if we had 3? So in that case, the fifth and the sixth point, they both would be the same, okay, and then when you average them out, you will find the same point again. So again, this is going to be 3 because the fifth one is 3, the sixth one is 3, their average is 3. So 3 is the median, but you need to understand that this median mark is not a data point. There is a data point, there are 2 data points with the value of 3, but the median cannot be considered to be as one of the data points if n is even, because we are taking the average of the n by 2th and n by 2 plus 1th term, which happens to be the same value as each of these terms, because both these terms have the same value. Okay, so that's the core idea of finding the median of the ungrouped data. Now let us go on to the grouped data. Now we have to understand what is the concept of cumulative frequency. What cumulative frequency necessarily means. Let us just do a quick recap of it. If I have an ordered data set, let's say the data set is again 1, 1, 2, 2, 3, 3, 3, 4, 5, 6, 6. Okay. Now, if this is the data set that I have, which is ordered, if it is not ordered, then you have to order it before, put it in order so that you can find the median. But I'm taking the ordered data set like this. So how many data points I have? What is the value of n? 1, 1. Okay, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is 11. Now you have to put, let's say that these are the marks obtained by the students of my class. So if I arrange them, so I'll arrange them in a table, and then I'll find frequency. What is frequency? How many students have got the same mark? Okay, marks are 1, 2, 3, 4, 5 and 6. So the frequency basically tells you, it is denoted by this lowercase f. Frequency tells you how many data points do we have for that particular value. Okay, so for 1 we have 2 data points, for 2 we have again 2, for 3 we have 3 data points, for 4 we have just 1, and for 5 we again have just 1, and for 6 we have 2 data points. If you sum them up, it is going to give you the value of n, which is 2 to 4, 4, 3, 7, 8, 9, 9 plus 2, 11. Okay. So this frequency f thing gives you the cardinal value, of a particular mark or a particular data point. How many, or the quantity, it shows you the quantity of data points with that particular value. Okay. So when you say that the frequency of 1 is 2, or frequency of mark 1 is 2, that means for the data point with the value 1, there are 2 data points which actually have the same mark, which is 1. Then for, let's say, 6, with the mark 6, you have 2 data points. So number of data points with the same value as 6 is 2. So this gives you the cardinal value, or the quantity of data points with the same value. Okay. Now, if you consider cumulative frequency, which is denoted as a CF, but we are going to denote cumulative frequency as the with the uppercase F. What happens in this case? So why do we take cumulative frequencies? Because when you arrange these data points of the data set in an order, let's say ascending order, then there is another thing which is called the ordinal number. Okay, ordinal number basically denotes the position, not the quantity. Cardinal is for quantity, ordinal is for order or position. So This point is the first one. This is second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. So the endmost data point will have the ordinal number associated with the thing which we call n. Okay. So the endmost data point at this particular end, which is 6, it will have the ordinal number 11. Okay, ordinal number 11. So that thing can be reflected if we use the cumulative frequency concept in a data set. How? So cumulative frequency, basically what this is the maximum ordinal number of that particular data point. So the data point 1 can have first position, it could also have second position. The maximum is second, so it is going to be 2. 2, however, cannot have first or second. It starts with third, because first and second have been already taken by 1. So this starts with third and goes up to 4. The maximum is 4. And similarly, 3 would have the maximum 5th, 6th or 7th. So maximum is going to be this, going to be 7. 4 is going to have only 1, which is the maximum itself, which is it's the 8th one. Similarly, 5 is going to be 9. For 6, it's going to be 11. Now, see, the cumulative frequency of the endmost data point gives you the total number of data points you have in the data set, correct? So, now you understand what cumulative frequency for the data point is. If for the data point, the cumulative frequency shows you the maximum ordinal number it could have in the arranged or ordered data set. Now, easily, when you try to find the cumulative frequency after finding the frequency, all you have to do for the first data set, you have to take the cumulative frequency exactly as the frequency, but then on, you just have to add diagonally. So 2 plus 2, 4, 4 plus 3, 7, 7 plus 1, 8, 8 plus 1, 9, 9 plus 2, 11. So this is how you find the cumulative frequency. You need to understand the meaning of cumulative frequency. It is the maximum ordinal number that a data point could have in an ordered data set. Okay. So this part is clear. Now let us move on to the concept of finding the median of a group data. See, because cumulative frequency is not going to be very much helpful. We can actually handle ungrouped data without the cumulative frequency, but it is actually helpful if the data set is large enough. Finding the cumulative frequency using the concept of cumulative frequency actually helps us pinpoint the location of the median easily. But it is more useful, and it is basically very essential for group data. If you have group data, I already have a group data with me. I'm going to give you the same here. Let's say there is a test that I have taken in which the full mark is set at 50, and I have collected the result. But instead of having individual marks of the students, I classify the entire data into 5 different classes. What are those classes? For class, from 0 to 10 is one class, 10 to 20 is another one, 20 to 30 is another one, 30 to 40 is another one, 40 to 50 is a class. Now there is also frequency, F, and then there is cumulative frequency, which we are going to denote as uppercase F. Okay. Now, one thing you need to understand here that anyone who has a mark between 0 to 10 would be put in this class. What happens if he has exactly 10 marks out of 50? Would he be taken in this class or would he be taken in this class? The convention is, if you have any mark which is the common of 2 different classes or 2 classes, then it is that particular mark is taken to be in the class that has the particular mark as the lower limit. So if someone has 10, you will find the class which has lower limit at 10. So this one is the class he is going to be put into. Similarly, if someone has exactly 30 marks, he will not be put into the class of 20 to 30, he will be put in the class of 30 to 40, because in the class of 30 to 40, the lower limit is set at 30. So some people could actually think that why do I have to take 10 as common? I mean, why do I have to take the classes like this? Why can't I have just instead of 10, I can have 0 to 9, then 10 to 19, then 19 to then 20 to 29, then 30 to 39, and then 40 to 49. Well, there are two problems. First, if I do like that, then if there is a student who scores exactly 50, he cannot be put into this data set or into the classification. And again, if someone has a fractional number, let's say 9.5, where would you put him? You can't put him in 0 to 10 or 0 to 9, or you can't even put him in 10 to 19. So that creates the problem. So there is double trouble. So it's best that we classify like this and use the convention that if someone has a mark which is common between two classes, then he is going to be put into the class in which the lower limit is the same as the mark he has obtained. So in this particular data set, let's say the frequencies are 5, 3, 4, 3, 3. So 5, 3, 4, 3, 3. Now, let us immediately write the cumulative frequencies as we've already discussed to find the cumulative frequency. What is cumulative frequency? Once again, it is the maximum ordinal number that can be assigned to that particular data point or data class, because we are actually using the concept of group data. There is no individual data point, there are only classes. So in this case, the frequency, the cumulative frequency denoted by uppercase F is going to be the maximum ordinal number that can be assigned to that particular class. So any those 5 students who fall within the first class, which is 0 to 10, could be first, second, third, fourth or fifth. So maximum being 5, you just write 5. Then the same concept goes on. Easily how you can assign cumulative frequencies to do the diagonal addition. So 5 plus 3 is 8 for the next one, 8 plus 4 is 12 for the next one, then there is 15, then 15 plus 3 is 18. And as we know, the cumulative frequency of the endmost data point, or in this case the endmost class, gives you the total number of classes, total number of data points or classes. Okay. So there are 5 classes, but each class has a different frequency. So that basically gives you the total number of data points here. If those data points, we don't know the exact data point, but we know that there are data points. The problem with group data is that it is based on individual data points, but it does not show the individual data points. Okay, it is based on individual data points, but it does not show it. So we can, even if we don't see the exact data points, we know that there are 18 data points which actually are the basis of the entire data set. Okay. Now we have somehow gotten a good grasp over this data that I have got. Now the question is how to find the median of group data. We've already discussed how to find the median of ungrouped data, in which we can see the individual data points. So finding the median by taking whether the n is odd or even is fairly simple and direct. But in this case, it is not so. Why? It's because there are no individual data points that we can see. So in any way, we are going to take some sort of approximation and averaging. So if in either way, in this group data, we are going to use some sort of assumption. In that case, you don't have to bother about the odd and even case, because in the ungrouped data, we used to take the ungrouped data if n is if n is odd, then you simply have to take the n by 2 plus 1th data point as the median. For n is even, if n is even, what you did is you took the average of the n by 2th term and n by 2 plus 1th term. You took the average of these two terms and you found the median. But you are in any way going to take some sort of approximation to find the median of group data. That's why you do not have to differentiate between odd and even. So what do you do then? So the concept remains the same, that if n a number of data points are there in the group data, then again median has to be the mark that in this particular ordered data set that separates the top half from the bottom half. So again, if the same concept, if this is the data set, assuming that, okay, basically we are making an assumption of an ungrouped data set corresponding to this group data set. Okay, so in this, let's suppose there is a median. Okay, let me just draw the thing out. Okay, let me just enlarge it. Let's say this is the data set which is ungrouped. Assumption. So basically this is the assumption that we are making based on the group data we have. So if this is the ungrouped data set, the median would be set somewhere around here, okay, and half would be to the left and half would be to the right. That means if the total number of data points is n, then n by 2 will be here and n by 2 will be here. Okay. Now there are classes in which there are different cumulative frequencies. Okay, each class has a different cumulative frequency, as we have as we have shown in the table that we have drawn. Or rather, should I just make a note of it here? Okay, let's just make it class frequency and cumulative frequency. So 0 to 10, n to 20, 20 to 30, 30 to 40, 40 to 50. The frequencies are 5, 3, 4, 3, 3. So 5, 3, 4, 3, 3. And the cumulative frequencies would be 5, 8, 12, 15 and 18. Okay, so that's the n, right? So now it is going to be very easy for us to visualize. Now this is the group data, but this is the assumed ungrouped data, which is which we are going to use to find the median, and this is the median mark. Median mark. By definition, it divides or it separates the bottom half from the top half in the ordered data set. So n by 2 lie here and n by 2 lie here. Now this median would definitely will be somewhere contained in the middle. That means if n is 18, the middle mark comes at around n by 2, which is 9. So if the middle mark has the 9th position, would it be contained in the first class? No, because it ends at the 5th position. The second class ends at the 8th position. Okay, so this is not, this two cannot be the median class. These classes cannot contain the median mark, but this can, right? This can, because it has the maximum ordinal number that can be assigned to it as 12. That means it can have 9th, 10th, 11th and 12th. So definitely this is the median class. That means median class means the class in which the median mark is present. Now, however, then going forward, there are the two other classes. The 15th one would, of course, if the median of this particular class 30 to 40 has the cumulative frequency 15, that means the maximum ordinal number that can be assigned to it is 15. You could also say that if it is 15, then it can also have the ninth position within it. No, because this is a very different class. This class is different, okay, from the class preceding to it. Okay, it cannot accommodate the point which are in any of these classes, any of these six preceding or succeeding classes, right? So the convention that we are going to use to accommodate this fact is that the median class has to have a cumulative frequency which has to be greater than n by 2 or equal to n by 2. So how do you find the median class? How do you identify the median class? The median class will have a frequency of the median class, I am denoting it like that, uppercase F with the subscript of n, has to be greater than or equal to n by 2, and it has to be, this is the first point, and second point is to be the nearest to the median mark. So the median, it has to be the nearest to the median mark. Which class is the nearest to the median mark? Only this one. Okay, so this one not only has a cumulative frequency which is equal to or greater than n by 2, it also is the nearest to the median mark. So that means this is going to be the median class. Okay. Now we've understood the median class, but that is not what we want to find out. We want to find out the median mark or the median of this group data. So how do you find that out? Here it is. So if this is the median class, the median class would be like this, somewhere around, this is the lower limit of the median class, this is going to be the upper limit of the median class. However, we know that the median mark is going to be contained within the lower limit and the upper limit, but it is not always necessary that the median mark will be exactly in the middle of the median class. It could be anywhere, okay, within LM and UM. We don't know. But what we know is that how many points would be there inside the median class, okay. Okay, in the median class, we know that there are 4 points, okay. There are 4 points, 1, 2, 3, 4. There are 4 points in the median class, okay. Now, there is another assumption that we have to make because we don't know exactly where those 4 points are because we have not been given the individual data point based data. We have to simply assume that these 4 points, because in the median class the frequency is 4, that means there are 4 data points. We have to assume that they are equally spaced over the median interval, okay, or the class interval, which is h. Let us say that the class interval is h. What is the class interval? It is basically the higher limit or the upper limit minus the lower limit, which is h, that is 10 here in our case. So the class size, it is also called the class size or the class interval, that is basically the width of the class found by subtracting the lower limit from the upper limit. So these 4 data points in our median class, if we assume that they are equally spaced, that means they are spaced. Each space would amount to how much? Each space would amount to h by 4 or 10 by 4. The class interval or the class size upon the frequency of that particular class. Okay, so h upon f is going to give us, the class size upon or the class interval upon the frequency is going to give us the spacing, individual spacing or the assumed individual spacing between the data points inside that interval. So h upon f is one of the things we are going to use. We know that much, but we are not concerned with all these 4 points. We only are concerned because we know the lower limit, okay. So if we could only count the spaces, these 2 spaces, we'll find the median mark. We don't have to bother about these 2 points. We know that they are there and we have assumed that they are equally spaced, but we are only concerned with these 2 data points, right? For that, what we have to do, we know that, let us just show it once again here, that we know that the total number of data points below the median mark is n by 2. So this is what we have, but we do not need this particular part. This particular part we do not need. We have n by 2 below the median mark, but if we somehow can take this shaded area, shaded length, we will be only left with the median, the points, data points in the median class which lie below the median mark. Okay, it could be 1, it could be 2, it could be anything. Okay, it could be 3 or it could be even 4. But how do we know how much there is between the lower limit and the median mark? How do you do that? See, starting from here, if we count all the number of data points till the lower limit of the median class, that would essentially be 5 in the first class, and in the second class this is 3. So total 8 number of data points which actually exist below the lower limit of the median class, which is 8, which is the cumulative frequency of the class that precedes the median class. So we denote that this particular shaded area as the cumulative frequency of the class preceding the median class, and denoted as the uppercase F subscripted by n minus 1. Okay. So if we take n by 2 and subtract the cumulative frequency of the class preceding the median class, we are going to be left with only this particular length. It doesn't matter how many data points are there. The maximum could be 4. It could be 0 even. But again, by doing this mathematical operation, we will know how many data points actually exist between the lower limit of the median class and the median mark. Okay. And once we find the number of points, since we have already assumed that all the points are equally spaced, so how many spaces do we have to count from the lower limit to get to the median mark? We simply have to multiply in the amount of individual spacing or assumed spacing, which is h upon f. So starting from the lower limit, if we calculate the number of spacings or assumed spacings before we reach the median mark, we are going to the median mark. Okay, so this gives you the median. Okay, so now for our data case, okay, let me just wipe all of those. Since you've understood the concept, how we get to the median mark, let me just make the board clear so we can write things easily and write things very neatly. So how do you find the median class? The median of the ungrouped data, if that is Z, that is the median, or let's just call it M. Okay, let us call it the median mark as capital M. The median mark M is going to be lower limit of the median class. We start from the lower limit of median class, and then we count the number of assumed spacings that we have to go through before reaching the median class. That is plus n, or has to be lowercase n. So it's n by 2. What is n by 2? It is the number of data points below the median mark. Okay, minus, this is the lower limit. So all the data points below the lower limit of the median class, and this is the cumulative frequency of the class preceding to the median class. If you don't find it, if you don't go by the cumulative frequency, you have to add all the frequencies of all the classes which precede the median class. The easiest way is to just take the cumulative frequency of the class which is the preceding class of the median class. So that is uppercase F subscripted by m minus 1. So you do F for F m minus 1. Those are the number of data points which lie between the lower limit of the median class and the median mark. Okay, so those are the number of data points. Since each data point is assumed to be spaced uniformly, then the total number of spacings that we have to cross to reach the median mark is going to be times total class interval, or the class interval, divided by the number of data points of the median class. So this is going to be the formula, right? Now you've understood it. If you just go through it again, if you don't understand, go through it again, and you will intuitively understand the meaning of this formula, so that you do not have to remember or memorize this formula ever again. So let us just apply this formula to our case. Okay, we know that n is 18. So if the total class size is 18, the median mark is somewhere around here. The n by 2 is 9. So this particular area is the length is 9. Now the median class, we know that the lower limit of the median class is set at 20. So the number of data points preceding the mark of 20 would be the sum of all the other classes which precede this median class, which is 5 plus 3 is 8. Or you can take the cumulative frequency, just the cumulative frequency of the class preceding the median class, which is 8. So there are 8 data points which precede the mark of 20. So out of the entire 9, you subtract 8, that gives you just 1. So that means from the mark of 20, you just have to cross one space, and you will reach the median mark. But that particular space is going to be h by frequency of the median class, because those many data points exist within the class interval, and we have assumed that they are equally spaced. So what is h? H is 10 in the class size. From 20 to 30, the class size is 10, and the frequency of the median class is 4. That means 4 data points exist in that class. So each spacing is going to be 2.5. So each spacing is 2.5, and we have to count just one spacing from 20. So how much we have to travel from 20? 2.5. So total. So this gives us the median as 20 plus 2.5, which is 22.5. So that is the median. Note that in this group data, there is nothing that could actually indicate, by simply looking at it, looking at the table, nothing is going to give us any evidence whether this, where the median mark is going to be. Only through this calculation we can come to an appreciable assumption, or appreciable approximation that the median mark would be around 22.5. So I hope you've understood this. If you haven't, then please replay the video and try to understand. If you still don't understand it, let me know in the comments and I will respond to you. Thank you.